So thanks for the introduction, Ellie. As Ellie said, I'm Robert Tyler from the Royal Borough of Kensington and Chelsea, and I quite like to shorten that to RBKC because it's less of a mouthful. And yeah, I'm here today with David and Chris just to kind of talk about the RBKC LED project that we've been working on for kind of a number of years now. So, I mean, in terms of what the RBKC LED project is, I mean, it's really a kind of a program of small to medium-sized projects. So the three main parts of that are the kind of development of background concentrations for the borough, which kind of AECOM's undertaken for us, and David's going to be talking about that next. We've also kind of the next strand is the kind of the development of the Kensington and Chelsea Category 4 and Category 3 type screening levels, which we're calling the KC4 and KC3Ls. And that's work that kind of I've done with David. So David's developed the KC4Ls, and kind of we've done the work with the KC3Ls internally. And again, David's going to be presenting those a bit later. And then to top it all off, the final bit is the RBKC LED model that kind of Chris has developed, and as Ellie said, he'll be kind of presenting that later. Kind of within the guises of the kind of the LED project are kind of a couple of other bits of work that we've been doing. So we've done a lot of work with kind of local plan policies and kind of developing conditions and guidance for particularly for kind of some of the smaller developments we have in the borough, where kind of lead is kind of regularly an issue. And we've also kind of undertaken some kind of King's Council legal advice, just to make sure that the kind of the approaches we're taking are kind of reasonable and legal, both through kind of planning and Part 2A. So that's the kind of LED project in a nutshell. I mean, hopefully I'm talking to the kind of preaching to the converted here, but I mean, it's always worth kind of asking why address lead in soil. I think we all know it's kind of toxic to people in the environment. It has kind of acute and chronic kind of impacts on kind of people. There's no safe level of lead in the blood, so it's kind of a non-threshold compound. And so kind of a LARP applies to it, so as low as reasonably practicable. It's also kind of wide, as I think most people here will know, it's kind of widespread in the environment for a number of reasons. Kind of in parts of the country, it's just naturally present in kind of rocks and minerals. There's, again, in many parts of the country, there's a kind of very long history over thousands of years of lead mining and processing. It's kind of been widely used in industry. It's widely used in in the past, it's been widely used in the building industry. So kind of lead flashing, lead paint, lead piping for water supplies. And also when kind of either owners of property or kind of builders import soils. I'm sure quite a few people have dealt with situations where that imported soil's been contaminated for various reasons. There's the kind of the wide use of lead within petrol up until the 1980s. Things like in the past, just the burning of wastes on kind of hearths, and then the spreading of ash in the gardens as some kind of fertilizer. Sorry, this is quite a long list, but I always think it's worth just kind of listing kind of the wide kind of use of lead in the past. Final two that I'll throw in things like the Blitz bombing during the Second World War, which impacted a lot of kind of urban areas in particular. and a kind of a nice novel one. I mean, in late 1800s, first half of the 1900s, it was kind of quite common to use lead arsenate as a pesticide in orchards in particular. And I mean, back in the late 1800s, there were within kind of RBKC and other kind of inner London boroughs, there were kind of more fields and quite a few orchards associated often with market gardens. So it's kind of a whole range of uses and kind of reasons that we might find it kind of in the soil, both in kind of urban areas, but also in kind of more rural areas as well, potentially. And again, I think we kind of, most people here will know that we have duties under Part 2A of the Environmental Protection Act to decide whether land's contaminated land, and also to address land contamination through the planning acts and associated kind of national and kind of local guidance. I thought it'd be kind of worth just mentioning that there are a few kind of duties that do tend to get forgotten quite often, which I just wanted to kind of really highlight. So under the Housing Act 2004, kind of local authority, kind of social and private landlords have a duty to ensure their properties are kind of fit for use. And kind of under the Housing Health and Safety Rating system, one of the hazards that needs to be considered is lead. So again, if you have high lead levels in gardens, it should be addressed. I suppose from a local authority point of view, there are also kind of local authority owned schools to consider and commercial buildings. There's also the Health and Social Care Act 2012, and the kind of the local authority has kind of duties to carry out research, provide information and advice, and also to kind of assist with the mitigation of risks. And although kind of land contamination isn't identified as kind of an issue that needs to commonly be dealt with, that doesn't mean that it shouldn't be considered. And then last but not least, there's kind of obviously the various health and safety acts and regulations. So kind of as employers, councils need to kind of ensure that their staff have proper training, kind of understand kind of risks they may come across during their work, and also to kind of provide appropriate PPE. So just for instance, at RBKC, we do have kind of corporate policies for kind of how to address land contamination issues, including kind of substances like lead. Right, so moving on. So in terms of lead in London, I think most of you will kind of recognise this map. It's the British Geological Survey London Earth lead map, and it basically shows from a lot of kind of soil sampling data undertaken by the BGS, the distribution of lead across London. And I mean, it's quite apparent that kind of inner and central areas of London have higher lead concentrations, and that these kind of reduce as you kind of move out to the kind of the outer lying areas of London. I've highlighted in the blue box there where RBKC is, and you can see, I mean, like kind of all the other inner and central areas of London, I mean, this map suggests that if you use the key on the right there, perhaps about kind of 80% of soil in the borough appears to be above the existing Category 4 screening level, and kind of perhaps I don't know, I mean 10 or 15%, maybe more, of the borough kind of appears to have concentrations where you would start to kind of think about whether the land needed to be determined as contaminated land. And I think it's worth saying with this map, I wouldn't necessarily use this as a constraints map, say to decide on planning applications, but I think it does give a good kind of indication of lead levels in soil, and I mean it's definitely kind of matches my experience of reviewing site investigation data for the borough. So I thought it'd be useful just to kind of look at a timeline of lead criteria. So I mean, many of you will kind of remember the good old days of the ICRCL, where we had a nice kind of round lead criteria of 500 milligrams per kilogram, which applied to kind of gardens and landscaping and parks. Yeah, I mean, all I can say, I suppose we've tried our best to get back to something like that. So in 2002, again, many of you remember the old SGVs, soil guideline values. So those were introduced, and that slightly reduced the lead criteria to 450 milligrams per kilogram. There was a period between 2009 and 2014 where we didn't have a lead criteria, which was a bit tricky. But then into 2014, we kind of finally got the Category 4 screening level, which is the criteria that we know today. And most of you will know that we have kind of, in terms of residential uses, 200 milligrams per kilogram for a garden with homegrown produce, and 310 for a garden without kind of plant uptake. And I mean, I suppose from kind of an urban point of view, that's obviously quite low, and as I've said already, quite a lot of soil in the borough kind of would exceed that. It's also worth noting that, and kind of mentioning that kind of in response to the Grenfell tragedy, we kind of RBKC kind of undertook kind of widespread investigations across the north of the borough just to kind of assess the impacts. And as part of that, we, or kind of, I should say, AECOM, generated what were called Step 1 and Step 2 criteria. And the Step 1 criteria was basically a Category 4 type screening level, and the Step 2 was a Category 3 type screening level. And those were, as you can see, around kind of 350 for the Category 4 and just over 650 for the Category 3. And so I suppose the good thing about that as well is a lot of that was kind of reviewed by kind of senior technical people in the Environment Agency, the UK Health Security Agency and Food Standards Agency. So I think that gives them quite a bit of weight. So, I mean, in terms of what we want to achieve, both for kind of Part 2A and planning with the lead project, and particularly with the development of the kind of Category 4 and the Category 3 screening level, is, and I should say that kind of for Part 2A and planning, you've got the column on the left, which is the current state of affairs, and the column on the right, which is what we kind of are hoping to move to. But I mean, as you can see, we basically want to move in both cases from a situation where about 80% of the borough exceeds a Category 4 screening level, to a situation where maybe 40 or 50% kind of exceeds. And then looking at the planning situation, I mean, currently where the Category 4 screening level is exceeded, kind of unless you undertake kind of DQRA, basically there's nothing to distinguish between kind of a not low risk associated with Category 3 land or a kind of a high risk associated with Category 1 or 2. And so obviously we want to move to a situation where we can distinguish, And so with a category 3 level, we'll be able to start to identify where a higher risk might exist. And of course, once you've defined the category 3 land area, if you exceed a category 4 screening level, you can start to put that into context. And so if it's just a very slight exceedance compared to the category 3 level, you might be able to say that no action's needed. If you're in the bottom half of the category 3 area, you might be able to say that a lesser amount of remediation is needed. If you're in the top half, then obviously kind of increasingly more robust remediation is going to be needed. Looking at the Part 2A side, if you exceed the category 4 screening level, apart from the British Geological Survey normal background concentration, which for urban areas is 820 milligrams per kilogram, you wouldn't, without DQRA, you wouldn't immediately know whether the higher risk category 1 or 2 is going to be kind of above or below that level. And kind of while kind of in theory, anything below the normal background concentration wouldn't be contaminated land, if there are risks, I think as local authorities, we do have a duty to kind of inform people and, where necessary, advise on kind of how to address risks from contamination. Just kind of in summary, the objectives of the lead project are basically to try and improve the quality of risk assessment for lead, and particularly in kind of urban areas, but there potentially would be kind of use for such criteria kind of elsewhere across the country. As I've said, we want kind of outputs that are more suited to areas with higher background kind of lead concentrations. And as I've said already, we want to achieve that by kind of increasing the value of the category 4 screening level. So I think it's really important to stress that in kind of increasing a level like that, it's only acceptable if you're still comfortably protective of health. And particularly for an urban area, I think kind of a LARP is kind of a really important consideration. Because if you can demonstrate a low risk at a higher number, which kind of cuts down on kind of remediation and arguably the unnecessary removal and replacement of kind of soil across parts of London, I think that kind of a LARP allows for that. It's not as low as reasonably possible. It's kind of practicable. So there's an element of kind of cost that comes into that. And kind of leading on from that point, we want to promote a more kind of sustainable approach to assessing and remediating soil. So that's the main part of my presentation. We thought it'd be useful just to have kind of a case study to kind of carry through each of the presentations. So I'm just going to kind of present that to you, and then we'll obviously move on to kind of David's presentation. And just to say, it's a made up kind of case study, but made up to be kind of representative of the types of investigations that we ask for in the borough and the types of concentrations of lead that we kind of find in the soil. So the case study it's a kind of an existing house which has been converted to apartments. It includes a garden of 20 meters squared, which is a kind of a reasonably good sized garden in kind of RBKC. It's kind of importantly not on or in the vicinity of a known potential site of contaminated land. And there are kind of, just because of what we know about soils across the borough and kind of made up ground, there's has to be the assumption that there's potential elevated lead levels. So in terms of the investigation that's kind of presented here, we have a CLC2 contaminated land planning guidance, which is kind of linked to one of our conditions, and it's specifically for kind of sites away from known areas of sources of contamination, and it actually sets out the absolute minimum level of investigation that we want to see. So in this case, that would be 6 trial holes with kind of 3 soil samples taken from kind of each of those, so 18 kind of soil samples in total. And kind of off those soil samples, I mean, we kind of require 4 to be for a full suite of analysis, and then the remaining 14 to be for a kind of a more limited suite for lead, possibly BAP, and asbestos, which are the 3 kind of common contaminants that we find kind of across the borough. In terms of the kind of results, and again, these are two scenarios. They're relatively common. Obviously, we do have land where there'll be lower levels of lead, and we also have examples of where we found kind of far higher levels of lead, kind of, as I said, away from kind of known sources of contamination. And yeah, as you'll see, I mean, in all of the results at each depth in both scenarios, we have kind of at least 1 or 2 elevated lead levels that exceed the existing Category 4 screening level. Kind of all of the means and 95th kind of upper confidence intervals exceed the existing Category 4 screening level, and kind of several of the medians do as well. And of course, kind of what that means in terms of the types of recommendations we see from environmental consultants, quite often without any kind of proper statistical analysis and with kind of far less kind of sampling, is that the conclusion would be that soil samples exceed the Category 4 screening level of 200. And the kind of conclusions and recommendation would be that kind of a clean cover system is required across that garden. And I think it's a really big question, kind of, is that necessary and is that sustainable? I think in many cases, I'd say no, it's not. And kind of a lot of remediation that takes place shouldn't really at all. So that's my presentation. So if I stop sharing.
Brilliant. Thanks very much, Robert. I think that was a really clear introductory presentation.
Thank you.
Great. So just a reminder, there'll be a joint Q&A after this for both Robert and David. So please do put any questions that you have for both of them in the Q&A function. But I will just now very quickly introduce David in the interest of time, because I know you have to leave, David, at 11. I'll do a shorter introduction. So just to say that David is a chartered geologist and accredited SOBRA risk assessor working in AECOM's investigation and remediation services team. And I'll put the full bio in the chat. So over to you, David.
Thanks, Ellie. Great. Thank you. Okay, welcome everyone. I'm going to talk about, as Robert's introduced, the RBKC background concentrations and then the development of KC4Ls and KC3Ls at Category 4 levels and 3 levels. So moving on, the first part of that There we go. So the background concentrations initially, we'll start off a few slides on this and then kind of circle back to how the background concentrations compare with the KC4Ls and 3Ls at the end. So where did the data come from that we used for this? Well, we took, and there's the same little image that that Robert presented, the London Earth, the BGS London Earth data set, and we've extracted the data points from within RBKC. I'll show that in a bit more detail on the next slide. The Environment Agency Soil and Herbage Pollutants Survey, so that's UK-wide data or England-wide data, depending on how you extract it or which country you're interested in. And the third map there is I mean, you can't really see the detail, but it essentially shows a chunk of North Kensington where most of the Grenfell environmental checks were carried out, and those were more targeted at different sites within that area around the tower. And so after collation of the background data, I'll show you some how that data looks shortly. The intention was to compare it with risk-based values, so the category 4 and 3 levels, to understand maybe where the health risks sits based on background, and how to take a pragmatic approach, and as Robert mentioned, to the assessments. So the London Earth data here, you can see the boundary of RBKC on this map, and then we've got the lead data points, and they are distributed reasonably on a reasonable grid, obviously not completely unbiased, probably moving things around away from obviously private, on public land samples were taken, but it's not a targeted investigation, so in theory, a relatively unbiased data set for statistics. And these are the data that we have used to look at the background levels in RBKC. You can see there's not really much parkland in RBKC specifically. It is all pretty heavily urban and built up. Some major arterial roads running through. So it's a very urban central London location. Okay, so just quite a few numbers on this slide, but just gives you a feel for the data sets that we looked at, and there is some graphical representations of these on the next slide, so I won't read through every number here. But you can see the different data sets we've used, the soil and herbage survey, and then we've got the London Earth within RBKC is the second column, and then two further most right columns. And then you've got London Earth all data, so the whole of London, and then we've actually got the entirety of the GBase data set, which is outside London as well. And you can see ranging from kind of 40 or 50 data points in the smaller sample sets, the soil and herbage survey and the London Earth within RBKC, up to nearly 45,000 data points in all of the GBase data. Arithmetic means ranging from 124 in all the GBase or nationwide to 602 actually within RBKC for London Earth, and the maximum concentrations again 3,800 within RBKC, an order of magnitude higher than that somewhere in the GBase data set, but within London the highest is 10,000 milligrams per kilogram. So there's some quite big numbers in there. I think just worth mentioning in terms of the data sets, the Environment Agency Soil and Herbage Survey, obviously that's a national data set, so we're not comparing that directly with London Earth necessarily. The Grenfell investigations, they were targeted at specific locations, so again not ideal for doing kind of broader statistical assessments on, and there's a lot, like I mentioned, a large variation in sample numbers. I think it is worth pointing out this point that the London Earth data points within RBKC the averages are higher than the other data sets. I think this does reasonably represent, if we go back to quickly to this slide, you can actually see how variable, and RBKC being somewhere in this where the real red colours are, and as you go further out, you start to get the blues and the greens. So and the parks kind of thing, Richmond Park down here in the southwest. So I think the fact that RBKC does have these higher numbers isn't a surprise compared to some of the data sets with that are broader and encompass outer boroughs or other areas away from London. If we move on to some graphical representations of these, then the box and whisker plots here, you can see that the lead concentration up on the x-axis and the different data sets, the box and whiskers of them across the y-axis. So the London Earth within RBKC is this the green data set here, and you can see the mean concentration is the little x here, the median, the line across, the percentiles forming the box. Some of the outlier data points coming up, we've limited it at 4,000, but if you recall, some of these other data sets had values beyond that. But again, this gives you the impression that within RBKC, this data set does have some of the higher concentrations compared to national data sets or even the wider London data set. And it gives an interesting comparison with the normal background concentration from the BGS. So the majority of data is below that, but there are points above that, obviously. And we'll come back to this graph when we compare with the KC 4L and KC 3L values. Okay. Okay. So yes, I'm now going to talk about the derivation of the KC4Ls and the KC3Ls. And starting with the KC4Ls. So really, we've taken the category 4 screening level for lead as a starting point. So I'm really going to talk about the changes from the derivation of the C4SL, rather than go through every parameter in the KC4L derivation. In summary, those changes are a reduced soil ingestion rate for a child age classes 1 to 6, a slight reduction in the outdoor exposure frequency, so down from 365 days a year to 292 days a year. That's for age class 2 to 6, and the age class 1 has come down to 144 days a year, down from 180 in the kind of the SR3 and clear approach and the C4SL. We've taken some soil to plant concentration factors from the location, the site-specific investigations around North Kensington from the Grenfell environmental checks, and the homegrown produce diet fraction has been factored down, linked to garden size, and that comes from Robert's experience of dealing with planning applications and sites within RBKC, and the understanding of what garden sizes really exist within RBKC, and therefore what reasonably or potentially people might be growing within the in situ soils. So to talk about these in a bit more detail, the soil ingestion exposure frequency, soil ingestion rate and exposure frequency. So the C4SL uses 100 milligrams per day. This has been reduced to 80 milligrams per day, essentially based on updated US EPA guidance from 2017. So the original 100 milligrams per day came from the 2011 Exposure Factors Handbook, and the 2017 update gives us a value of 80 milligrams per day. This is the value taken. This is an extract from it from the 2017 guidance, and we've got 1 to 6 years. I don't know if you can quite see that, but that says there's an 80 there with a kind of range 60 to 100. So we have taken that most likely central tendency value estimate as our soil ingestion rate. Yeah, and that's essentially what we're saying there. So the exposure frequency has also been reduced slightly, as I mentioned, and just a little bit of commentary on that. In terms of CLEAR and C4SLs, the documents, or certainly the C4SL document, acknowledge that the outdoor soil and dust ingestion is unlikely to occur every day of the year, but 365 days a year was adopted as a cautious approach. So for the KC4L, we have tweaked it down a little bit. So for age class 2 to 6, the outdoor exposure frequency has been reduced to 292 days a year. And essentially that's a 20% reduction from the C4SL, which equates to, and this is where the, judgment in terms of what's reasonable and appropriate. So the garden is still used 7 days a week from March to October, so 2/3 of the year. But in the winter months, or 4 months between November and February, the assumption is that a child would use the garden maybe 3 times per week. Or, if you're away from home for 2 weeks, 14 days in the year, that actually, so, on holiday or something, or visiting relatives elsewhere, that actually comes up to 4 times a week, essentially, even in those winter months. So that's considered to be a reasonable level of outdoor exposure frequency for the KC4Ls. And for age class 1, it's a 20% reduction on the SR3 assumption, which is also used for the C4SLs. So that it's the same percentage reduction as used for the age class 2 to 6. And that's down, so that's down from 180 to 144 days per year. I have got a slide later on which explains that you can't just put these exposure frequencies into CLEAR because of the way it calculates GAC and SSAC. You need to do a time-weighted soil ingestion rate. But because the lead tool, which Chris is going to discuss later, doesn't have that problem, I might talk about that if I've got time. The time or the exposure frequency weighted ingestion rate approach you need to use for the CLEAR model. So moving on, homegrown produce diet fraction, one of the other parameters that's been adjusted. So actually we've derived KC4Ls for a range of garden sizes so that Robert can, or whoever's doing the assessment, can pick and choose a value related to the size of the garden within a development. And the range of garden sizes, as I said, is based on Robert's experience of what the reality is in kind of a densely populated urban area of Kensington and Chelsea. And the assumption being that the smaller the garden, the lower the quantity of homegrown fruit and vegetables that you'll be able to produce for consumption. So you can see the values we've used here, and essentially any garden that's 60 square meters or more, but we use the same homegrown produce diet fraction as C4SLs, and then that progressively reduces as the garden gets smaller. So anything between 40 and 60 square meters is 75% of the homegrown produce diet fraction. 20 to 40 square meters is 50%. 10 to 20 square meter garden down to 25% of the C4SL diet fraction, and very small garden of less than 10 square meters would just be 12.5% diet fraction. So that's the approach we've taken, and I mean you can see that's applied to all of the produce types. You can see the values there. Don't need to read those out though. So the final main parameter that's been adjusted, the soil to plant concentration factors. As I said, these are taken from Borough specific data from the Grenfell Environmental Checks project, and in that project we collected crop and paired root zone samples from 14 locations. The samples were spread across all 6 of the CLEAR produce types, and you can see, I mean, there's some photos there of the kind of things we were collecting: big bags of vegetables, soils, and those went off to the lab. Ferrer doing the crop analysis. And the table there just gives a summary of the values we've used. So you can see we've taken the mean soil to plant concentration factor for green vegetables and root vegetables, and that was just because we had a few more samples of those types of vegetables. Again, we're reasonably precautionary there because we've not taken the geometric mean. We've gone for the mean, which is a little bit higher, just so we're not pulling things down too low. And for those crop types where we didn't have as many samples, we actually took the maximum value we had. So again, just to stay precautionary enough, due to the smaller data sets, we've gone for the maximum soil to plant concentration factor. And you can see how they compare to the clear defaults. They are generally they're generally lower, the concentration factors, although not always by a huge amount. Tree fruit there, for example, is only a couple of times lower than the clear default, as is shrub fruit. So those are the parameters that have gone into the derivation of the KC4Ls. And they'll all get listed out on a slide near the end, the actual derived values, but this, moving on to the KC3Ls and what else has changed within those. The key thing really is further reductions in exposure frequency. So for outdoor exposure frequencies, come down to 170 days a year for age class 2 to 6 and 84 for age class 1. Indoor exposure frequency, I'll explain a bit about that, has been reduced to 292 for age class 2 to 6 and 144 for age class 1. And the other big, I guess, major change is the change in the index dose, or the toxicological threshold. So we've increased from 1.4 to 2.1 micrograms per kilogram body weight per day, and that, again, I'll mention that on the next slide, or one of the next few slides, what that is based on. Here we go. Okay, so as I said, the health criteria value changed from 1.4 to 2.1 micrograms per kilogram body weight per day. The first row there, between so the tox didn't change. For the KC4Ls, it's the same as the C4SL, but for the KC3L, we have increased it, and the 2.1 is essentially equivalent to a blood lead level of 5 micrograms per deciliter, which is the UKHSA concentration for triggering case intervention in England. And that is taken from the C4SL research project report. The conversion of that, the 5 micrograms per deciliter to the 2.1 is all discussed in there. So that's the approach decided and taken for the case for the KC3Ls. Exposure frequency, the other major change. So again, these are numbers that have been discussed within guidance reports, within the C4SL report, not adopted for the C4SLs, but for the KC3Ls, they were considered reasonable for the purpose of the KC3Ls, which is not necessarily low risk. And the 170 days a year for age class 2 to 6 is roughly a child using a garden 2 times a week between October and April, and 4 times a week at other times. The age class 1, which is down to 84, it's really, we're keeping that assumption consistent with SR3 in the infants. It's the proportional difference from age class 2 to 6, and the SR3 justification there is that infants before the age of 1 are not afforded the same access and exposure, and are kind of kept more protected from this kind of exposure, and that's why that's a lower value. Indoor exposure frequency, slightly different, and this is for lead only, or dependent, but you can't just necessarily apply it to any contaminant. but it represents a nominal 20% reduction as a pragmatic means of reflecting other local sources of dust. So if you look at SR3 and the C4SL reports, they have studies that found between 20 and 80% of dust originates from sources other than the garden, with an average of about 50%. And the USE proposes US EPA, a default mass fraction of soil to indoor dust of 70%. So this is a 20% reduction in that exposure frequency to account for non-garden soil sources in indoor dust. Doing on time, 6 minutes. Okay, so I think I will come back to that one if I've got a minute at the end. That's just how you need to approach this for clear. But given that we've got the lead tool that Chris is going to talk about, it may be that people are not using clear a lot for this approach. So let me quickly present the KC4L and KC3L values, and then you can see them compared there against the C4SL. So the KC4Ls range from 395 milligrams per kilogram, that's for a large garden, to 430 for the tiniest garden, less than 10 square meters. And then without homegrown produce at all, 436. The KC3Ls, as you can see, ranging from 810 to 911, depending on garden size, and 928 for residential without homegrown produce. And again, that's obviously not a screening value for planning. That's more Part 2A. We're not talking about low risk necessarily there. So those numbers clearly a bit higher. But as you can see, very roughly, a couple of times higher than the C4SL for the KC4L is a couple of times higher than the C4SL for the residential scenarios. Okay. So circling back to how they compare to the background within RBKC, hopefully you can see the little lines, the horizontal lines there. There's a yellow one which represents the range in values of the KC3Ls, and they're very, very similar to that, as you can see, the BGS normal background concentration there. And then the lower down horizontal line, the kind of bluey color, which is the range of the KC4Ls, and you can see they hover somewhere at the lower end of the background box and whisker plot for the RBKC background from the London Earth dataset. A little above the boxes for some of the other datasets. So that's where these risk-based screening criteria fit. And for the purposes of the objectives of this project, they're useful. They're helpful. They're helpful in the context of the project, in that they're still well within the KC4Ls anyway, still well within the kind of background levels of the borough, but do also demonstrate risk-based health protection. There is the little the box on the right here just saying that there is an option for RBKC to consider the London Earth arithmetic mean of 602 for use as a screening value. I mean, something kind of in the technical note that we've prepared. That again, that's very much needs to be taken by and it would be a decision for Robert, for example, to take a well-informed expert contaminated land officer, and it could be used only when there's that strong case under planning to meet the minimum requirements. That land should not meet the definition of contaminated land, but maybe the lower threshold of low risk is not needed. That's quite a specialist decision to make, though, and but it's just something to bear in mind that 602 milligrams per kilogram, the mean value in RBKC, does fall roughly in the middle of the KC3Ls and the KC4Ls. Okay. And not necessarily that helpful text summary of what I've just said. So I'm going to move on because I've got one more slide, which is a quick implications for Robert's earlier case study scenarios. So I've taken the two scenarios that Robert presented on his earlier slide. You can see the data there, the hypothetical data in this site. And as Robert said, I think there's an assumption probably for that currently, if you're looking at using just the 200 milligrams per kilogram C4SL, that there would be quite a high chance that of a proposal to put in a cover system, maybe even a 600 mil cover system, unnecessary or potentially unnecessary excavation and disposal of soils and replacement with imported soils. If we look at the KC4L, if we take the value of 425, I don't know why I've put square meters there, that should clearly say milligrams per kilogram, is the garden, which is square meters, so that will be for the 10 to 20 square meter size garden. So the squares, the averages of the exceedances of the KC4L are shaded red on the slide. So you can see actually the deeper soils may be reasonable to keep in place based on the KC4L, and actually a shallower cover system might be perfectly reasonable down to maybe 20 centimeters in this garden. And in the context of it also being presumably a communal garden, as Robert said, changing to flats, it may be that that the residential without plant uptake might actually be reasonable to use as well. But essentially a cover system less than a 600 is absolutely reasonable. And for scenario 2, not quite as clear cut. The average concentrations across the garden are higher than the KC4L generally, and the mean and median in the deeper soils are lower, but the 95% upper confidence limit is above it. So depending on how cautious you want to be on that, it may still be appropriate to argue that a shallow cover system is acceptable on a kind of a sustainability argument, and also taking in this maybe where you could take into account the fact that the background concentrations, for example, the 602 arithmetic mean from London Earth is above that 587 value. So there's an argument that could be put forward even in that scenario that the shallower cover system is quite reasonable to employ. And I think that's the end of my time and my presentation, so I will stop there.
Thank you very much, David. I know you've got to head off now, but hopefully we can have you back for the panel discussion.
I'm planning to be back.
Yes, that would be great.
Somewhere between 12 and half 12, probably. So
perfect. So only gone temporarily. We'll have you back, and then hopefully we can pick up any specific questions for you then. But I do think actually, Robert, that it looks like quite a lot of the questions in the Q&A, hopefully you should be able to take them. So we'll go into the Q&A now. Thanks to everyone who's put questions in the Q&A box. I mean, still got time if you want to add them in now, and we have the panel discussion at the end, but we can pick up anything outstanding as well. So first of all, we've got a question from Anthony McNichol, who asks, is there a disclaimer for the KC4Ls and KC3Ls to say they're specifically for use in developments within RBKC? Are you able to answer that, Robert?
Yes, I mean, I think Chris is going to say something about that as well, particularly because we presented the levels within the modelling tool. And so there is a kind of a disclaimer and limitations of use. And I mean, I suppose we talked a lot about kind of how to format those. And the way we decided to do it is kind of to say that they are for use by RBKC, but also recognizing that others might choose to kind of use them as well. And obviously that's for them to decide.
Okay, great. Yeah. Thank you. And then we've got a question from Sam Johnson. Sam asks, which threshold would RBKC expect to see used as a GAC for new developments and planning? KC4Ls or KC3Ls. And then goes on to say, if a lead concentration in soil is, say, for example, midway between KC4L and KC3L, what level of further assessment, if any, will they expect to see?
So I think, primarily for planning, I think, as David said, it would be the KC4L. And obviously, I think the purpose with the Category 4 screening levels was always that kind of people might take those and do site-specific, generate site-specific acceptability criteria. So, effectively, what we've done is we've done that for people, and they can obviously choose to use them. So, it's difficult to comment on particular situations. That would obviously be for an environmental consultant to advise and for the individual local authority to decide on. But if you've got levels between the KC4L and 3L, I suppose my opinion would be that you would probably need some form of remediation, because the Category 3 land is by definition not low risk, which doesn't really meet the kind of the requirements of suitableness for use in kind of many cases. So I hope that answers the question.
I think that's comprehensive. Thank you very much. I can see we've got quite a few more questions coming in, so thanks everyone for adding those in now. So I'm going to go to Nick's question, because Nick was actually the first person to ask a question, and nice to see you're here, Nick. So Nick says, RBKC seems to have an extensive suite of planning conditions and informatives. Is it possible to share?
Yeah, of course, yeah. I have shared them with the London boroughs before, and kind of fed into the NCLOG kind of planning work as well. But yeah, if anyone kind of wants a copy of our conditions, they can always just kind of email me.
Yeah, you're very approachable.
I know Nick, so I'll email him afterwards as well.
Perfect, great. Okay, then we've got some new ones coming in. So a couple ones around specifically gardens. So Adam says that's a lot of sampling in garden areas. What has been used to derive the sampling frequencies? And I think that comment was for your presentation.
Yeah. I suppose, in my opinion, the quoted levels of sampling kind of isn't enough, really. In many cases, you would actually need more samples to be able to generate kind of more solid statistics. Just from experience, I've done a lot of kind of investigation work myself in kind of small, medium-sized gardens, and it's partly from my kind of own experience that generally that's what you would need as a minimum to be able to, well, not to have to go back at a later date if you find kind of exceedances. So I suppose there's that. I think it's also well in line with BS 10175, what's required through that. And I suppose the other point is that type of investigation is aimed at kind of existing kind of gardens. And the whole idea behind it is that you undertake the investigation, you use the KC4Ls, and you should be able to get a good idea as to whether you can leave the garden as is or whether work is actually needed. But I'm always interested to hear what kind of others feel an appropriate level of kind of sampling is. So, yeah.
There we are. Great. We've got loads of questions. This is brilliant. So yeah. Frank Westcott asks, how do the SPCFs derived by RBKC compare with the Newcastle allotments biomonitoring study? If you know, Robert.
Yeah, no, that's a good question, and they're broadly similar, kind of similar orders of magnitude. I think Chris knows a lot.
Yeah, I can see Chris has got his hand up. Do you want to come in, Chris?
Do you want to say something, Chris?
Yeah, I've compared those and they are very, very similar. So they're in the same ballpark. So it points to the EA ones being far too high, essentially. And that for urban soils, the Newcastle and the RBKC work is probably a better indicator of what may be present in urban type soils and that type of lead that might be present, as opposed to the work that the EA based their factors on. And I'll go into that in my presentation a bit. The model gives flexibility on that as well. So
yeah.
Thanks, Chris. Good to have you here to jump in. And feel free to jump in at any of these questions. Okay, so going on to a question now from Rebecca, who asks, where a shallower cover system can be justified, would our BKC be looking for something to be put in place to prevent soil mixing?
I suppose, my view would be that if you've undertaken sufficient investigations and you've demonstrated that existing soils are kind of reasonably around or kind of below the Category 4 level, that there wouldn't necessarily be a need to stop soil mixing unless you suspected that there was something that you hadn't identified through the investigation work already. But yeah, I think, and again, this goes back to the whole point that we know that kind of a large proportion of the borough exceeds existing Category 4 screening level, and it is just not practical to kind of remediate 80% of the gardens over the next, say, 50 or 100 years. So just from a sustainability and soil protection point of view, it's not reasonable.
Yeah. Okay. I guess this question follows on relatively nicely then. So Mark Heron asks, in domestic gardens, if a shallow 20 centimetre cover of soil is used over lead contaminated land, can fruit trees be planted and fruit harvested? If it can't, is this not, blighting the future?
Again, it's similar to the last point. If you're replacing the top 20 centimetres of soil across a garden, it's because it's not suitable for use. But you'd obviously expect anything a reasonable depth beneath the 20 centimetres to be suitable. And I think what we tend to find with lead is, as many people know, you tend to find it at higher concentrations near surface, and then as you go down to deeper depths, the concentrations, not always, but quite often, decrease.
Okay, thanks. Some of these questions I might leave until the panel discussion at the end because they're a bit more overall, but we've got a more specific one from Corinne who just asked for some clarifications. She says, not sure if I missed it. Can you explain the NBC lead of 820 milligrams per kilogram stated?
I suppose it's kind of the kind of urban domain normal background concentration published by the British Geological Survey. I think it's probably about 10, 15 years ago. Probably, no, 15, maybe more than 15 years ago. And under Part 2A, kind of below that level, kind of if you read the statutory guidance, anything below that level should be considered Category 4 land, irrespective of kind of risk. And then anything above that level, you would need to start considering under Part 2A of the Environmental Protection Act.
Yeah.
Yeah.
Yeah. Okay. Thanks. I guess if you have a link to that, what was it? I can't remember the standard that you said at the start. Maybe if you have a link to that and put it in the chat, that might be That might be useful at
Yep.
some point. Great. Okay, then just a few more left. We've got a question from Alex, who asks, have you considered bioaccessibility as a way of determining what is acceptable rather than changing the category 3 and category 4 levels without knowledge of how much can actually impact the resident?
Yeah, I mean, that's been a big consideration. I mean, personally, I always like to see bioaccessibility testing. I think that's also something that's picked up through Chris's presentation, looking at the modelling tool, because that's one of the things that we also want to get over and kind of make simpler for risk assessment.
Okay, great. Well, Alex, hopefully, yeah, Chris will go into a bit more detail on that then, and feel free to ask another question that we can bring into the panel if you want more information. Okay, well, we're kind of at the time that we said for the Q&A now. So I think we'll bring that to an end. All the questions that we've got here, I'll try and bring back during the panel discussion anyway. And that then gives you a bit of a break, Robert, from all the questions, because you are on your own. You're supposed to be two of you. So we'll go over now to Chris's presentation, or I should say demonstration, part 1. Then just to remind everyone, after that, we'll have a break. Then Chris will do part 2 of his demonstration, and then we'll go into the panel discussion with all of the speakers. Okay, great. So Chris, let me introduce you first, actually. So Chris is the Technical Director at Peak Environmental Solutions. Chris has worked in land contamination for over 35 years in both consultancy and remediation. And Chris now specialises in technical land contamination risk assessment work, focusing on human health, VOC vapours and controlled waters. So over to you, Chris.
Brilliant. So today I'm going to talk about how we implemented the 3 Ls and the 4 Ls into a sort of bespoke Excel-based tool, and take you through it in part 1, just through the sort of some of the technical aspects. And then part 2, after the break, we'll go into actually demonstrating the model. I'll dive straight in. So structure of the chat will be, what does it do, who's it for, what we were trying to achieve, how we sort of implemented that in Clear and in Excel, the Clear modelling approach and the benchmarking. And then we'll go into the demo after the short break. So what does it do? This was just a quick little phrase of it. So it's a Excel-based bespoke human health Clear modelling type tool for inorganic lead, and it addresses the 2 main residential Clear land uses of residential with homegrown produce and residential without homegrown produce, Resi plus HGP and Resi without HGP. And that it does that for 3 baseline conceptual models, the category 4 screening level conceptual model, and then the 2 RBKC conceptual models at 4L and 3L. And also allows you to do site-specific CSMs as well. It's now available to download. I'm hoping some of you have downloaded and managed to have a play with it via the Claire wall. So thank you to Claire for hosting that. So if you know what you're doing, that's all you need to know. You can leave the presentation now, so because it should all be obvious. Right, so who's it for? So I've designed it really for experienced assessors and people who obviously know what they're doing. You should be familiar with the Clear approach and lead modelling. As a user, you're responsible for justifying the use of the tool and the inputs. They're provided by RBKC for lead DQRA within the borough, but the intention, or my intention and RBK's intention, I'm sure, is these conceptual models could also be considered by assessors outside of RBKC. And the good thing about the tool is it enables you to model both 4L and 3L, but also category 4 screening level conceptual model and do your site-specific CSMs. So it's quite a flexible tool and can deal with those 3 CSMs and site-specific CSMs as well. Just a reminder, using the tool in the outputs, they are your work. They're not RBKC's work, so you have to justify them. And model outputs themselves, remember, they are not the risk assessment or the risk evaluation. They have no meaning. We as risk assessors bring the meaning to the inputs and the outputs. The tool does have a basic guide, but it's not a clear manual. So you need to know what you're doing. But we also hope that the tool will be used for sort of teaching and learning about how clear works and give you some deeper understanding of what it's actually doing. So the design objectives was build it in current Excel, make it accessible fast, maybe dare I say even fun to use, provide the main tool on a single spreadsheet with the modeling done in real time, and to give you insight into what is going on underneath the hood. So didn't want it to be a black box model, and I didn't want any back to guide or find AC buttons. So I've come at this, not my first model building experience. So I've already built a full clear model in Excel, which I use in my practice. And that does 20 substances at once in real time for soil, vapor, groundwater. Can deal with, I've added in 2 soil layers and building VOC membranes. I've also recently modified the existing 1071 as an experiment, because I know people were having trouble with Microsoft 365. So I've solved that, and I'm currently trying to deal with the AGS and EA about trying to find a way of getting a Modify 1071 out there to people who are struggling. There's also the clear info maps that I produced there on Sober. I'll be showing some of those. And we also sort of run a clear mentor group for about usually between 15 and 20 people. We meet maybe 4 or 5 times a year to chat over things about clear. I've also built an RTM model, various other tools. So I've brought that experience into this new clear LED PB tool. Right. So we decided to use Excel, better or worse. Could have done it in Python. Well, I couldn't have done it in Python. Somebody could have done it in Python. But we decided Excel was accessible, I suppose, to many people, and so it's out there and people can use it. We opted for a macro-enabled file, so that comes with its own set of problems, because there are sort of hurdles to overcome, and we'll chat about those a bit further. So it can only work in Excel. It won't work on web browser Excel version at the moment. It won't work in Google Sheets or Apple Numbers. Sort of works in LibreOffice, but LibreOffice has some problems with the VBA, Microsoft. Also tried to use simple coding and formulas, very little EBA. And then we put it out to beta testing in October, December, to about 10 people tried it out, tried to break it, came back with some great feedback. So thank you to all those testers. It was great help. So some general housekeeping about it. The first hurdle you're going to have to overcome is getting past the Microsoft and organizational controls on macro and VBA use. So this is something you have to deal with any spreadsheet or Word document that's got VBA in it. So you'll just have to overcome that to enable you to get to the main tool. There is very limited VBA in it, but they're there to make your life a bit easier. So we did decide to include some VBA, but you'll have to obviously make sure that you've got your security and everything in place, and remain vigilant when sending, receiving, and using VBA enabled spreadsheets. The tool is password protected, just to make sure you don't delete anything by mistake. That's not a security feature per se, but it will obviously prevent some tampering with the thing. But always make sure you know where that spreadsheet has come from if you're receiving, and just be a bit mindful about sending them around. Excel's also got some font scaling issues when you're zooming in and out, so you might see some cell spill, which has proved a bit frustrating in generating the tool. So try and keep it above 90% zoom, and you should be fine. And then there's some other quirks and issues that I've just detailed in the spreadsheet. I've already spotted one little typo as well, but we'll probably have to do some sort of errata and maybe some future release, but we'll see how that goes. So it's been fully benchmarked in 1.071, both in the EA version and in our own version, and it seems to all work fine. And then within the tool, we've given you two distinct approaches to benchmarking the tool within Clear 1.07. So we've got a sort of process that you can demonstrate that the tool is actually doing what it says it should be doing, and you can replicate that in Clear 1.071. It gets a bit funky, but I'll take you through that at some point, and that was alluded to by David in his talk with the soil ingestion pathway. So, quick chat about what we've actually done in implementing the Clear approach. So, thankfully, inorganic lead isn't as complicated as some substances. So it's relatively simple as things go. Just to be clear, this is a backwards calculating model. So this starts from the health criteria and works backwards to the allowable, acceptable soil concentration that delivers 100% of the average daily exposure for that CSM. As we're dealing with the two RESI conceptual models, we're looking at a female child age class 1 to 6. And the model gives you essentially three starting points you can choose from, either the category 4 screening level or 4L or the 3L KC values. And it's really, really simple to switch between those models in real time. Bang, 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 it does it. And then the model gives you 6 outputs per CSM, 1 for each of the 5 garden sizes and without homegrown produce. So you get 6 outputs per CSM in real time. And then you can then move away from those 3 conceptual models, and there's a lot of flexibility, and you can essentially generate your own conceptual model very, very easily. And then get back to the starting points very simply as well. So lead uses the same health criteria for both oral and inhalation pathways, and that's discussed in the phase 1 PB category 4 screening level. And the model gives you two toxicological criteria to select from, one being the LLTC of 1.4, and the second being the 2.1 micrograms per kilogram body work per day used by the KC3 LCSM. And you can flip between those two in your own site specific, or it will just default to the relevant one depending on which CSM you adopt. Just on the side, one thing you've got to remember is that the 1.4 value is designed to deliver 3.5 micrograms deciliter. I think that's the right units in blood lead, and then the 2.1 delivers 5. So essentially what the category 4 screening level is saying is at 200 you get 3.5 in your blood. So if you doubled that or trebled that, you would obviously get double that or treble that within blood lead levels. So if you had under the category 4 screening level conceptual model, if you had a concentration of 600, you would expect your receptor to have near enough 10 micrograms per deciliter in the blood. So you can start to see if you've got an RBKC scenario where you regularly got 600 in the soil, for example, is there a cohort of children out there with 10 or so micrograms per deciliter in their blood? Probably not. So this is probably where there's the feedback loop to say that 200 may not be working as well as it should in delivering a realistic endpoint for what was actually going on in AC 1 to 6. Right. Oh, important there, so I missed there. There are no dermal pathways modelled because under category 4 screening level, the dermal absorption factor is 0, and there's no modelling of background. So there's no NDI, no 50% rule to worry about, which makes my life as the programmer a lot simpler. There's a lot less maths and formulas and calculation checks to worry about. So we've considered 6 pathways in the tool. 4 of those are modelled directly from first principles, and so that's soil ingestion, the main homegrown produce pathway, and then the secondary homegrown produce pathway, which is the soil attached to those produce. Now, what we've done with the soil ingestion pathway, because of the way that the RBKC conceptual models essentially have different exposure frequencies for indoors and outdoors, we split that pathway into 2 separate pathways, so that we have a soil and soil dust ingestion outdoors, and then a soil dust ingestion indoors. Soil ingestion is essentially 3 sub-pathways. You've got ingestion of soil outdoors, ingestion of dust outdoors, and then ingestion of dust indoors. So we've combined the outdoor ones into one pathway as an ingestion rate and a set of exposure frequencies, and then we've taken the dust separately indoors, and we model that as with its own set of ingestion rate and exposure frequencies, and that's simplified the approach down. You don't then have to have what you would have to do in clear is essentially fudge the ingestion rate to take into account those varying exposure frequencies. And one of the key things is that the RBA affects the soil ingestion pathway and the soil attached to HG homegrown produce pathway, but doesn't affect the main homegrown produce pathway. So there's only 3 of those 4 that are affected by the RBA. And then for dust, we, instead of doing that from first principles, which we could have done, used a bit more of a simplistic approach and then used a lookup table. So you select your, well, it's either done for you via the baseline conceptual model, or you can then select some other changes in the parameters for the indoors and outdoors dust pathways. That will become apparent when I do the demo. Dust inhalation is a bit funky because you've got an outdoor dust level, outdoors you're breathing. You then take that same air into the house, you breathe that, and then you have a separate pathway that brings dust, soil on people tracked back into the house, and then that then becomes a dust fraction as well. So indoors you're inhaling both dust from the outdoors air and also dust that's being generated by tracked back soil. So it's again, that's 2 pathways for the indoors and essentially 1 pathways for the outdoors. And then this over here is one of the clear info map things that gives you a little bit of feel of the overall things. And I'll go into a bit more detail on that in the demo. So this is one of the other clear info map sheets which are available at SOBRA and things. So essentially, it's just a little summary to say that what we're dealing with. There's no vapor inhalation, obviously. We've got soil ingestion outdoors, soil ingestion indoors. Let's see if I can just do a laser pointer at me. Soil ingestion outdoors, which is soil and soil dust, and then soil dust indoors via tracked back soil. And then we have dust inhalation, which is both outdoors and indoors. And then we have 2 homegrown produce pathways, consumption of the produce itself, and then consumption of soil attached to the homegrown produce. That can actually be dust as well, dust on leaves of the lettuces and things. So it can be soil and soil dust again. So it's again two sub pathways really. And somebody mentioned about deep rooting tree fruit. Within the model, you'll be able to do a deep dive into the significance of the homegrown produce by produce. So the model should give you some further information to make some judgments about the significance of deeper rooting tree fruit within that pathway. So that should help answer whoever somebody raised that question. Oh, right, okay. So Ellie, do you want to have a break now before I get into the main model?
Yeah, that's good. We're ahead of schedule. And I think, it'd be good to go for a break now. Everyone can get a cup of tea and get ready for part 2.
Questions now before we take the break on what I've just gone through? Would that be? So we'll go from PowerPoint, we'll swap across to a live demo in Excel. So what we're going to do is talk about spreadsheet and associated tabs that go with it. So the key thing is that the tool fits onto one big page in Excel. It should print across 2 A3 PDF pages. And what we've done is split the model into sort of 15 areas, 15 zones. And we'll go through each of those. We've also got separate tabs for about the license disclaimers and information about the model and etc. And then we've got a basic user guide, and then we've got a tab that shows worksheet that shows the technical basis, which draws upon the the presentations that Robert and David have given. So the 15 zones, essentially, the model, the actual live model that does the calculations is sort of this bit in here. These are sort of added extra areas, and then these bits are just some lookup tables. And the main calcs are done in these areas here. So it's not that complex, but there's a lot of, it is quite information dense, and there's a lot of things you can get out on what Clear is doing underneath the hood, and also change all the parameters that are going into the model as well. So what else have I got moving this one? So this is going to be the order. It's just mainly for me, so I can see what's going on. We'll go through in this order and might be able to answer some questions on the fly. So let's see if we can. Yep, let's stop sharing that, and then we'll go straight into the Excel. So I'll just show you this one briefly. So this is the model that you will download, but I'm not going to use that one. I'm going to do is just so you know that looks the one I'm going to show you has got a few more tabs. This is the one I'm going to use. So I'm just showing you, because you won't see in the model you download, you won't, these are just extra tabs I've added to give some other slides essentially within the presentation. So when you open up the model, you'll have to get through the you'll usually get some warnings up here about macro use. So you'll have to overcome those within your Excel setup and organizational to actually get to the get the model to work as it should. So the first page that it will come into will be this tab here, the license disclaimers, and that gives you information on, from RBKC. Robert has developed this text here about what the tool's based on. We've got some information in this cell here, in this box here, about macro use, some recommendations on what you're doing, and some guidance to UK guidance, Microsoft guidance about macro use, little QA version log. And then over here is this, we've got who the model is intended for, which replicates some of the slides that we gave earlier. So the key thing is that this is produced by RBKC for use within their borough. So that's the primary use of it, but we recognise that they will be of interest for risk assessors to use outside the borough in their own practice, as it were, to develop their own site conceptual models. We would not expect the generic assessment criteria, the 4Ls and 3Ls, to be used as generic assessment criteria outside of RBKC, unless that can be agreed, obviously, between the risk assessor and whoever they're dealing with in terms of the regulators. And the use of the tool rests with the risk assessor. And then we've got some commentary here about system requirements, printing, and a set of known issues that we've already gone through some of those, which might become a bit more apparent. We can't move that. So you can see, then we've got a basic user guide. This is essentially while we're following this user guide through the spreadsheet, going from area to area. And then technical basis, just a summary of the input parameters that have been adopted for 3L and 4L, replicating the talks by David and Robert. As you can see, there's no tab showing for the tool. So this is my proudest feature of the whole tool, is this little checkbox system here. To get access to the tool, you have to agree to the terms and conditions, and the license legal status. And as soon as you press that, the tool tab magically appears down the bottom here. You won't believe how much hassle that caused me. But I did it. So there we go. So once you've checked those terms and conditions, you can then get access to it. This will uncheck every time you exit the spreadsheet. So when you reopen it, again, you have to agree to the terms and conditions. Right, click the box. So there's the whole model there in one big zoom in. So try and keep it above 90% if you can. If you don't, if you go below, you can see you start to get this Excel inherent problem with font scaling and cell spill. It starts to look pretty ugly. I can't do anything about that. It's just the way Excel works. So you just try and keep your zoom a bit higher. So you can see we've got these blue boxes that tell you which zone you're in. And then, so the idea is to sequentially move through those, and that will enable you to go from inputs to outputs, and then looking at various insights into what the model was doing under the hood. So the first area zone is zone 1, usual sort of stuff. You can put in your project details. So the way the model is set up is that we've got yellow, light yellow and bold yellow are your user inputs where you can put information in. Everything else is cell protected, so you can not change other stuff, but you can basically input into the yellow zones. There's quite a bit of, there's some conditional formatting things to help you understand what you've changed and not changed, and when you've moved away from a baseline conceptual model parameters. So usual stuff, put your information in there. That's zone 1 done. Then we have the main input area. So most of the time, this is probably where most of your work will be getting undertaken. And this controls essentially the primary pathway inputs. And we've got these little buttons here. These are one of the limited bit VBA. So this enables you to move between 4L, 3L and category 4 screening levels with a single click. So if you click on that, this will load all of the category 4 screening level conceptual model parameters, and it will essentially load it up for you. It will, if you've done any changes, it will delete what you've already done. So to prevent that, if you want to stop that, you can uncheck this box here, will disable these so you don't accidentally delete your work and your conceptual model that you might be putting in. So you can move between category 4 screening level, all the parameters there. Press that button, that will take you to 3L. Press that button, takes you to 4L. So you can quickly move from conceptual model to conceptual model. And what you'll see happening in these cells here is you move between the models. These will tell you which set of default values you are basically implementing. So you can see the conditional formatting in these changes as you move from conceptual model to conceptual model. So we'll start with the conceptual model that everyone's familiar with, the category 4 screening level. And this will essentially load all of those for you. And then you can go to the yellow cells, and then these are all a variety of either direct inputs or drop-down menus. So here you can, for your toxicological criteria, you can select 2.1 or 1.4. We've restricted you to that. And you can then see these other cells then change the interaction. You can see what's going on over here. It's all done in real time. Your model's updating. And then this cell here is basically giving you a little bit of feedback loop, just to remind you that you're within the 3L conceptual model, or you're within the 4L or category 4 screening conceptual model. And then we've got, you can then select a framework for your soil to plant correction factors. So we've given you 4 options here. You can either adopt the category 4 screening level SPCFs, or you can adopt the average max ones for the 4Ls that David talked about. We've also given you another option. You can adopt the maximum values of the RBKC ones. So you've got a little bit more flexibility to play around essentially with the soil to plant correction factors, or you can input your own ones. And there's a box down. So you can decide, tell the model which set of criteria you want to use. And then these will then change depending on which conceptual model you are in. So within the category 4, it's adopted the category 4 screening with the soil to plant correction factors. So that's set your tox criteria and your soil to plant correction factor framework up. You've then got the soil ingestion pathway input parameters. So here you can select your combined soil ingestion rate. At the moment, it's in the category 4 screening level. If I went to 4L, that would drop it down to 80 automatically. You then tell it how you want to do the split. So do you want it 50-50 split between indoors and outdoors air? Indoors and outdoors soil ingestion, or do you want to change that split to some other ratio? And that will then translate down to here to give you your actual indoors and outdoors ingestion rate in milligrams per day. So you choose your global one here, so you could go to 80 there, and if it's at 50-50, then down here you get a 40-40 split indoors outdoors. And if you get confused, you can just then go back to safety, one of these buttons, and it'll reset everything for you. So let's stay within the C4 SL conceptual model. So that's 100, 50-50 split. And then you can see indoors, outdoors, your ingestion rate is 50-50. If I wanted to change that to 40, it would then 40% outdoors. It would then change the indoors and outdoors as correspondingly down here as separate ingestion rates. You've then got your main control over the RBA, which is a primary thing of interest for risk assessors on site specific. The default is 60% within the category 4 screening level. You can change anything between 1 and 100 and 0.1 fractions. So these are all a bit, you can't put, say, a negative number in here, it won't let you. So there's data controls on formats to prevent you putting the wrong number in as best I can. I'm sure you can find ways to get over that. But I've tried to prevent you not putting in a value that is appropriate. Again, the same here, you can go from anywhere from 1% up to 99%, and it will update everything in real time. And you can see that things are changing colour. If I move away from the default, cell changes colour. Likewise here, if I move away from one of the defaults, either 80 or 100, the conditional formatting will flag that up as a non-standard input parameter. And then for the soil ingestion pathway, we've split the pathway into two, so you can have independent exposure frequencies. So you can see under category 4 screening level, the numbers are the same in both columns. Indoors and outdoors frequency are the same. When you go to the 4L, because of what they've essentially reduced the occupancy outdoors, those numbers now change. So you've got the category 4 screening level exposure frequencies indoors, but outdoors they've been reduced by the, I think, 20% number or something. And you can see, you can then get back to safety again, or you can go straight to by pressing these buttons into those. And then that just confirms in these boxes that you're in that conceptual model. And again, you've got these little checks here, just confirming, letting you know which conceptual model you're in.
Chris, I'm just going to jump in because we've had a question.
Yeah.
Oh, it's just disappeared. It's just been deleted, actually.
Okay.
So it was from, okay, well, if the person has deleted it, we'll leave it. But if they post it back,
I'm intrigued.
I'll jump back in. Yeah. Okay. All right.
So this gives you complete flexibility over how you want to separate out the soil ingestion rate and how you want to apportion that. On an early build of the model, I tried to essentially do as Clear does and treat it as a single ingestion rate, but I couldn't get it to work when you had different exposure frequencies indoors and outdoors without fudging it as a single soil ingestion rate. So made a decision just to split it into two pathways, and it works really nicely. It benchmarks, it does everything it needs to do, and it gives you sort of that insight into how those two separate pathways are working. Then we move down the model here. This is the soil to plant correction factor for homegrown produce. And these are the parameters here. So this is what the model is essentially calling upon within the 4L, 3L. There's the alternative all max values. It's just these two values here I've gone to the higher max value as opposed to being a mean value. Then we've got the EA defaults in here that the model calls upon when you select that back up here. So when you change this cell here, it will then call upon the relevant parameter here, or you can put in your own soil to plant correction factors in these boxes here, and then you can call upon those via this site-specific one up here.
I'm going to jump in. We've got the question back.
Magically appeared.
Yeah, magically back. So it's from Sam Johnson, who asks,
Yeah.
does the, well, they say, hi, Chris, and they ask, does this model, there we go, does this model allow you to adjust bioaccessibility, which was briefly discussed earlier, or can chemical data be copied across to Clear UK version 1.071 for this?
Well, you wouldn't need to do the chemical data because this is specific for lead, so it's already preloaded. And there's the RBA. That's how you change the RBA there. So yes, you can change the RBA directly in the model there. Just put your percentage in there. you have decided is representative of your site.
Great,
So-
thanks. And we do have another question from I think it's Nathaniel, but I put that in the Q&A box for later. And Sam says thank you, Chris. So
Right, brilliant.
back to you.
Right. So that's the base, sort of the basic. Most people will be just probably looking at deciding on their conceptual model framework, 4L, 3L, category 4 screening level, and manipulating the RBA. I would say most people will be using that, or you can then start to do site specific. Then we've got a set of advanced inputs where you can dive into changing more specific values. Here we have the conceptual model for the homegrown produce. So you could here manipulate the exposure frequency by age class for homegrown consumption. So this is the currently default category 4 screening level values that were adopted both for 4L and 3L values. But you could manipulate those. So you could say, I only want age class 2 to consume homegrown produce for 180 days a year. Again, that will flag up that you've gone for a site-specific conceptual model, moved away from a default value. If you go back, it will then flag it back up again. And then give you flexibility on changing the advanced homegrown produce values. So you could manipulate the percentage of the homegrown fraction that you're consuming. You can change the soil. This is for soil attached only, these ones here. You can change the loading factor, preparation factor, dry weight factors for each of those, manipulate those, or just leave them as default. One of the nice little tweaks here is for the dust pathway. Clear 1.07 is a bit obtuse about how it deals with dust in terms of how it looks at giving you the area. So what I've done is simplified that and given you a site area drop-down box. Default is 0.01 hectares, not a very big area. And then we've got different dust generating areas. And then you can basically, then you've got two options for how much of that dust generating area isn't dust generating. So the hard cover, vegetated cover fraction. Now giving you two options to select from, either no cover or all cover. It's only a minor pathway. And then you can also manipulate the percentage RBA for inhalation, which is different from the oral RBA. So you can move away from 64%, as you said. So this is quite useful for exploring. If you had a bigger development, you might want to set the dust generation area within your red line area to say 5 hectares, 2 hectares. And essentially that will generate more dust and then lower the output for that pathway. And we'll explore how that works in a minute over there. Just within so I could turn this into a clear demonstration about how clear works. And I didn't really. How long have I got, Ellie?
I think we said for you to go until 20 past. So that's 2 minutes. But
okay.
actually you're in the agenda. That's because you started early. But if we keep you to the original time in the agenda, that's 25 past. So that will be 7 minutes.
Right.
So
okay.
that's a bit better. Should we go for that?
Yeah, please do. Otherwise,
yeah. Okay.
I'm gonna have to stop. So I won't turn this into a clear lecture. I could do. So that's all the inputs. And then over on these sections, We then got, once you've got your inputs, you then you've got an area where you can provide justifications for your CSM. These are automatically populated cells based on what you've used. So you can see that they are sort of hot linked. If I went to 3L, these would update accordingly and give you a sort of a summary of your conceptual model. And if you then moved away from default, it would tell you you've gone site specific on a certain parameter. So it just sort of streamlines your justification, and then you've got put some further notes in there, and you've got some further areas here to add more notes. So this is then the output area. So what we've done here is broken down as best we can information on by pathway. So the way I've set the model up, whereas Clear 107 is more, all the calculations are done via essentially by intake. The way I approach it is I treat every age class as essentially a separate pathway. So what this is telling you here is for age class 1, for the soil ingestion pathway, if you were just running that pathway by itself, that output would be 530 milligrams per kilogram. So that is a separate pathway. What Clear then does is essentially lots of sub pathways all stacked upon each other to give you the age class 1 to 6. So essentially every age class delivers a soil concentration, which are then harmonic meaned, reciprocals, so 1 over that number, add all those up, 1 over and back again, and that will give you your age class 1 to 6 number, which is this number here. So all of those numbers there are reciprocal harmonic meaned into 629. So we have a set of numbers for the indoor soil dust ingestion pathway. We then have a set of numbers for the outdoor soil ingestion pathway. And they're the same under category 4 screening level because the exposure frequencies are the same. If you went to 4L, you can see those numbers are different. So this is the indoor pathway giving you a lower number because there's more exposure, because the exposure frequencies are 365. And then you go to the outdoor, lower exposure, higher number. Those two numbers are then a harmonic mean into the combined number that gives you the 100% AD. As you can see, it's some sort of pro rata of those, but lower. So 437. So under that 4L conceptual model, the soil ingestion pathway gives you 787, 983 to 437. And you can see how all of that is built up by age class. And then this gives you a little reminder, this is automatic, what conceptual model you're adopting. And then for indoor and outdoor pathways, it's a lookup table. So it takes the parameters that you've used or defaulted. Let's just go back to soil ingestion first. There's a little chart here that shows the harmonic mean and these outputs graphed here. So you can see how some age classes are above it, some age classes are below it. And then all the calcs are done here for soil ingestion. So these are all the calculations by age class, give you all the parameters and all the intermediary steps, so you can see how the calculations are done, both for indoors and outdoors. You can start to understand what Clear is doing. So all Clear is really doing is taking the health criteria, times it by the body weight, that gives you your allowable concentration a day coming into the body. It then sticks that concentration into the soil ingestion rate, and then that essentially tells you the concentration that's allowable in the soil. That's all it's doing. It's really basic. So then the dust pathway, you choose your conceptual model. It then just goes to a lookup table over here. So it essentially finds the area you adopted, finds the percentage hardcover you've adopted, delivers this value as a lookup table back to this cell over here. And again, we've got a indoor and outdoor number. So the outdoor, I've given you completely unrealistic numbers above 1 million. Impossible, of course, but because it needs to benchmark to clear, I've given you the actual number. Otherwise it won't benchmark. If I limited that to 1 million, you wouldn't get the exact number coming out of clear, 1.071. So that's an impossible number. It's just saying it's a very big number. So they, again, harmonic means into the combined dust pathways. The dust is relatively minor. You can see they're really big numbers. And then for the homegrown.
Sorry, Chris,
project,
I'm just checking in because we are at 12:25. I don't know how much longer you have to go. We could maybe do a couple more minutes, but just so you wrap up. Though we have had a very nice comment in the chat from Alex who says, "Take as long as you need, Chris. This is the best training course I've had in years." So there you go. Well, I'm going to say take as long as, maybe take a couple more minutes. But,
I might need a couple. I might need more than a few more minutes, but I will try and speed up now. I'll try and speed up.
If we can maybe 5 minutes, then I think that'd be okay.
So then homegrown produce, we've then got the 5 areas under the category under the KC models. Essentially, this then delivers the outputs according to the percentage of homegrown fraction. That's all that essentially has been done. So this is the category 4. 100% homegrown fraction, and then each garden size essentially reduces down homegrown fraction. As you can see, the number goes up. And then over here is a little graph that, no, that one doesn't show that one. So there's another graph somewhere else. I'm running out of time. So much I want to talk about. And then we have homegrown produce with no homegrown produce, which is in one of these, that is there without homegrown produce. So the model then takes these outputs and then combines them together. So you get the final SAC outputs are here by garden size. So you get 5 outputs by garden size, depending on the homegrown produce, or you get the output that ignores homegrown produce as an SAC minus HGP. So you essentially get 6 outputs per model, and they are then graphed over here. And you can see garden size, no HGP, and then they're graphed. And then these are 2 bounding numbers depending on. You'll have to have a little explore. And then the soil and the homegrown produce again has got a very detailed breakdown by age class. These are the outputs here. So by age class, by veg type. So you can see how the model is working for each age class for each veg type. So tree fruit, age class 1, a really big number, going to be a low risk. And then here you can see the percentage of the ADE for each veg type. So you can see that the main one is green veg. Under that, green veg root veg, tuber veg, tree fruit, not probably not going to be that much of a risk. Again, all harmonic mean. And then similar for the soil attached, you can see it's a minor pathway compared with the main pathway. This one's affected by RBA. This one's not affected by RBA. And then we've got just a couple of summary tables here that gives you your outputs, breaks it down by ADE by pathway, so you can see which pathways are contributing most to the risk. This is not necessarily the same as pathway contribution in 1.071. That works slightly differently. I wouldn't use it. ADE is the way to go. And then there's just a set of baseline references. If you moved away, you can just have a quick lookup table here. You can see each of those within the RBA percentage changes as well. There's a lot going on, which I would probably need another hour or so, probably by the looks of it, to talk about. And then you've got some more graphs to look at, give you some more flavour of what the model's doing. And then down here are two methods to replicate any output within Clear 1.071. I'll leave you to work through those, but they're little tools that you can put things again. Yellow areas you put your numbers in, and you can benchmark any number. And it also gives you a mean, a way to derive the soil ingestion rate that you would then use in Clear. Follow the guide, and it should get you there. I'm starting to lose my voice, so there we go. I think I want to stop there then. By the looks of it, Ellie, is that about right?
Yes, that's about right. Thank you so much, Chris. And I think obviously that comment I read out in the chat, you can't really get much higher praise than that, really. So thank you very much. I mean, if there's a need and appetite for it, and you'd be interested, I mean, I think NCLOG would always be happy to host any more kind of like, you know, one-off webinars if there are specific things that you feel it'd be useful to go over again. But we will focus now on the final bit of today, which is the panel discussion. Really, Robert, I'm just going to bring you up here as well, and also David, good to have you back. I mean, we've still got a lot of questions in the Q&A, so I don't know, maybe it's just worth using this time to kind of to go over those. I don't know how you want to do it. I'm happy to field them to you if that would be better, or Robert, if you want to lead.
I mean, maybe if you could read them out.
Yeah.
Because I'm slightly limited with my kind of chat and to a degree my Q&A because of our security. The first thing I'd like to say is just a kind of a massive thanks to Chris and David. I mean, they're kind of an element of what they've both undertaken has been kind of paid work, but I'd say, I mean, based on all the time, probably 70 or 80%, if not more, has been kind of voluntary, which kind of we really appreciate, and I think it's very admirable of them both to kind of do all this work for the greater benefit as well. So thank you.
Yeah, absolutely. Thanks, Robert, for starting with that. I completely echo what you said. And actually, our first question does also start along the same lines. So we have a question from Kate, who says that the RBKC model and the beta version of Clear that Chris has been working on are both extremely valuable tools that support risk assessors in their daily work, and for which he should get widespread thanks. And then Kate goes on to say, has the EA made any comment on the use of these unofficial tools rather than the official Clear tool? And similar to Adam's question as well, of, you know, will this approach be accepted by regulators? So I don't know who would like to start there.
I mean, I suppose just from an overall point of view, we did actually meet with the Environment Agency to discuss the tool, and they seemed, they they obviously can't endorse individual approaches, but they were kind of interested and seemed pretty happy with what kind of Chris has produced, and with the KC values as well. And as I said before, I mean that's as kind of expected with the derivation of any kind of SSAC.
Yeah.
So I think it's within the scope of clear. I don't know if Chris or David want to add to that.
For the 1.071 mod, so there are discussions ongoing. That's all I can say at the moment. So with AGS and the EA.
So maybe this is a kind of watch this space.
Yeah.
Response. Okay, thank you. I'm then going to go to a question from Wendy. That's had a couple of thumbs up. So if a property if an existing residential property with an existing garden is changing to apartments with no external works, what is the justification for requiring sampling of soils, given that the risk/use isn't changing? If anything, the risk may be reducing as the garden would be more likely to be a communal one. Is this something that you request as a norm?
Sorry, what was the exact development again? Was it?
So if it's an existing residential property with an existing garden and it's changing to apartments with no external works?
So I mean, I suppose there's a few things you can say with that. I mean, first of all, I think if you read the National Planning Policy Framework as it is and proposed, any development like that should land contaminations and material consideration. And I mean, it is, although you're not knocking down the building and redeveloping it, it is a new development. So land contamination issues need to be considered. It's also very clear on the planning application forms within the existing use section that kind of where a future resident of that property might come in contact with soil that based on kind of available knowledge might have lead in it, you would need to submit a preliminary risk assessment with the application, and obviously kind of a lot of the time the local plan policies, which obviously vary between authorities, would also require a preliminary risk assessment. So yeah, I think it's kind of quite clear from a reading of kind of policy and the application form. And I mean, the land, although you may just be doing works to the building, the land's obviously material to the use of the building. Yeah.
Okay, great, thank you. And then a couple of questions that are pretty similar. So from Greg Gibson and from Ed Bullivant. So Greg asks, are other London boroughs close to RBKC planning to take a similar approach to what you've done in terms of adopting C4 and C3 levels for lead? And then Ed Bullivant asks, how does this work relate to other urban areas across the UK, or do you consider this work specific to inner London only?
Yeah, I mean, good questions. I mean, I suppose, I mean, I did reach out to other kind of London boroughs and nationally to see if anyone would be interested in collaborating, and that wasn't taken up. So yeah, we've obviously gone it alone. I mean, it's up to other London boroughs whether they kind of use the levels. I mean, in terms of, I mean, you could argue that because, I mean, although we've designed it for urban areas, I mean, it is a Category 4 screening level. It is reflective of a low risk. So, I mean, it's quite possible that if a rural authority found elevated lead levels, they could also consider the conceptual models associated with the RBKC work.
Okay. Thank you, Robert. I guess also I would say, you know, before we didn't have the NCLOG Regions Forum before, so maybe now if you were starting from scratch now, you'd be better able to be connected to CLOs working across the country.
Also to add, you can obviously use the model within the Category 4 screening level framework CSM and use it to manipulate that baseline model. So it just gives you the tool just gives you 3 starting points, and you can choose how to do your DQRA accordingly. And that's the risk assessor's choice on how they want to approach that. We've just given you 3 within the model, 3 starting points for a DQRA essentially, and you can decide how you want to go about that outside of RBKC. So it's not a case of, is it an acceptable? It's just another set of frameworks that an assessor could consider in their DQRA. If I want the DQRA.
Okay.
So.
Thank you, Chris. Okay, better race for it because we've technically only got 5 minutes somehow. So I've got a question from, well, the username is CP Nathaniel. So given in 2024, the government advised that while there is no defined UK threshold for the harmful effects of lead in children, a blood lead concentration, BLC, of less than 2 UG/DL to more than 5 UG/DL is now widely accepted as the clinical threshold above which investigation should occur and a source should be identified. So it's a very long quote. I'm just going to post it in the chat as well so you can see it. But the essential question is, why is RBKC using such high blood lead levels for risk assessment in a development context? So let me just post that in the chat now.
I mean, if I could just quickly say something, and then obviously David and Chris might want to add. But I mean, I think the UK HSA kind of quote equal to or greater than kind of 5 micrograms per deciliter, which is obviously what we've set the category 3 level to. But I don't know if anyone else wants to comment on that.
Well, I'll just come in. I think, I mean, correct me if I'm wrong, Rob, but well, the 5 micrograms per deciliter is for the KC3L, which is not something that you are automatically considering using for development under planning, is it? That's not really the case.
That's more as a kind of a starting point for Part 2A.
Yeah. So I don't think we are using the, and if that came across, then it shouldn't have done. It's, you know, it's there to kind of guide, as I said, I think expert practitioners such as Robert, who understand where it lies in the grand scheme of things under Part 2A and category 4 and low risk and planning and all that kind of consideration, but it's not being used. Those KC3Ls are not going to be used as a matter of routine or maybe ever for making a planning decision on a development where low risk is needed.
Thank you.
Okay, I don't quite understand the language of why is RBK using such high blood levels. It's not being used. It's been the health criteria is 1.4 LLTC, which is based on a blood level endpoint of 3.5 micrograms per deciliter. So I think it's not a fair characterization to say that that's a high blood level. They may end up via the conceptual model to end up at a high soil concentration, but the model endpoint is 1.4 micrograms per kilogram per body weight as the modelled endpoint. Just because the soil concentration is high doesn't mean the resulting blood level is higher.
Okay.
I don't quite understand that frame of question.
Right. Hopefully Nathaniel's responded in the chat. I don't know if you guys can see that.
Oh, it's above 2. Yeah, that's undoubtedly. It's not such high, but it's above 2. But it's also less than 5. But it's not such high. So it's in line with the category 4 screening level. And I know Paul has a problem with the category 4 screening level LLTC, so that's a different conversation. But that is the government guidance. So
yeah. Well, I think you guys have, you set out your position, and hopefully Nathaniel can see that. See, there's lots of questions that we're not going to be able to get to, unfortunately. I don't know if you guys are happy for people to kind of contact you if they've got additional questions afterwards. I mean, I'm sure your emails could be found on the internet if people wanted to. But okay, maybe we'll pick like one or two to finish off. Okay, we've got a question from Anthony who asks, would selecting the KC4L be acceptable for assessing soils that are stripped and reused on site in landscaping or for imported soil?
Yeah, that's kind of an interesting question. I mean, I suppose in principle, some authorities might accept that. I mean, generally we want where soils are kind of imported onto site, we want them to be of a kind of better quality. But as I think, I mean, we make clear within our kind of advice that, I mean, if you're obviously reusing soils on site, then there's obviously a sustainability gain there as well. So they might be suitable for use.
Okay, great. And then we've got someone joining at this time. We've got I'll do final question from Ayub from the UK Health Security Agency, who asks, the study sample was limited to central London. How was the map developed? Are percentage 95 CI correct? The data is spatially correlated. Any thoughts on that? I can also paste it in the chat so you can have a look at it in writing as well.
I can see the question.
I'm not. Which map is it referring to? Is it the kind of the London-wide one?
The hotspot map is not what map that we've developed. That's the BGS map, isn't it?
Yeah.
The only other map that we presented was the data points located on the site. That I think that the 95%. There is a slide which shows 95% CI. I don't think that. I think that is actually the CL. It's the upper and lower confidence limit. It might be a small case L. I don't think there are any confidence intervals presented there, upper and lower confidence limits. But if it's a question about the map, the hotspot or the kind of map, the heat map, if you like, then that's not our map. That's the BGS London Earth map.
Okay, great. Well, again, maybe Ayub, if you want to possibly follow up, if you've got further points to make on that one. Okay, well, I will have to bring us to a close because we are already over time. I guess a good point would be to say, as I've mentioned before, we do have our lead forum coming up on the 24th of March. So, you know, some of these questions you might just be able to come along and ask them on the 24th. And I'll put a link to that in the chat now, though that is only for NCLOG members. So that leaves me just to say thank you so much to our speakers. Thank you, Chris. Thank you, Robert. Thank you, David.